Hello, we're back with Chapter 5, and we're looking at this chapter with the idea of finishing off our the resistive circuits area, and we'll be moving on to the reactive or the AC circuits with the next chapter. But we're still looking at one more topic in AC or in DC circuits, and that's what we call loop or mesh equations. So mesh equations or loop equations are the way that most electrical engineering students solve the current and the voltage problems that we've been looking at from chapter 2, 3, and 4. And we use Kirchhoff's voltage law, basically, that says the sum of the voltages around any closed loop have to add to zero. And we get multiple equations and multiple unknowns, and we go for the, and that's basically how we solve these questions. So as we go through this, these examples, realize that this is an area that electrical engineering students pretty much favor, and it gives them an avenue that they can just basically, you can just kind of close your eyes and get an answer, and it gives you a very, very good answer, but it also, there's a price to pay, and in this case, it's the price is you have multiple equations and multiple unknowns. So again, in this situation, what we do is we look at the panes. In other words, there's a window pane right here and there's a window pane right here, and we take a circular motion and we draw a clockwise motion of the currents in each one of these, and we say I1 is in this first pane and I2 is in the second pane, and then we just start writing equations. So we write Kirchhoff's voltage law starting at the lower left hand corner, and we say they have to sum to zero. So basically here we say what? Minus 9, and then up here is the 6 ohms times the I1, and then we say here in the middle, it's what's the current through this resistor? Well, in this pane, it's the current going down, or it's the current I1 minus I2. Do you see that we have now two currents? We have this one and we have this one. So if we say I1 minus I2, we can represent the current going down, and then that times 3, and then we can say that has to equal 0. So minus 9 plus 6I1 plus 3 times I1 minus I2 equals 0. Minus 9 equals 0. So we rearrange, and we have so many I1s and so many I2s, and before we do that, we go through and we do the second pane. Second pane is we have the 2 I2, and then right here we have the I2 minus I1, or 3 times I2 minus I1, and that's equal to 0. So here's our two equations. 6I1 plus 3I1 minus 3I2 minus 9 equals 0. And then the second one is 6I2 plus 3I2 minus 3I1 equals 0. Now we rearrange these. We call this standard form. So you have so many I1s, so many I2s, and then you come down here and you have so many I1s and so many I2s equals something. Okay, so that's how you do that. And you also have what we call linear algebra. So this is a problem with a linear using matrices, and you can use matrices if you want to. You can also solve these equations a number of different ways, and you also have calculators that can solve these equations. So you can find a number of different ways to solve these two equations. And however you decide to do that, you're going to find that I1 is equal to 1.25, I2 is 0.75, so I1 minus I2 is 0.5, so 0.5 milliamps, or 0.5 amps, is what's flowing down in that 3 ohm resistor. So now we've found all the parts and pieces of those resistors, the currents through each of the resistors, and we now know how to solve that question. It gets better as we get more equations, though. See, this would be how would you do this equation? How do you do this problem with a crunch method? Well, it'd be very difficult. If you did Thevenin, you Thevenize, and you Thevenize again, and you could do it, but it would only leave you with the value over here, and then you have to work your way back in order to get the rest of them. This way, what we have is what? Well, we have all the three equations, and they're all done simultaneously, and then if you want to solve them simultaneously, you can. So here we have minus 10 plus 2i1 plus 4i1 minus i2. So that gives us the first equation. We can simplify that down to 6i1 minus 4i2 equals 10. The loop I2 equation is 6i2 plus 8i2 minus i3 plus 4i2 minus i1 equals 0. So in this one, the I2 is the dominant one. It's I2 minus I3 over here. It's I2 minus I1 over here. And we have to add those together. We equal to 0 because there's no power supply. Or you can solve down to minus 4I1 plus 18, which is 8 plus 4 plus 6, 18I2, minus 8I3 equals 0. The I3 loop is 10I3 plus 12I3 plus 8I3 minus I2 equals 0. Or again, 8I2 minus 8I2 plus 30I3 equals 0. Written in standard form, arrange the i's so that you can see the pluses and minuses. And you have 6I1 minus 4I2 equals 10, minus 4I1 plus 18I2 minus 8I3 equals 0. Minus 8I2 plus 30I3 equals 0. And you can see that the cross of these, the cross diagonals are equal. Minus 4 and minus 4, 0 and 0, 8, minus 8 and minus 8. So that's a good check to see that if they're right. And there's that symmetry in every one of these problems. You'll see that symmetrical cross diagonal. Okay. Now, so that gives you an idea how to solve these problems. We're going to go again looking at another one. Here's 5-3. In this circuit right here, we're going to do the I1 loop, the I2 loop, and the I3 loop. We're going to do those. Okay, so the first one is the 3I1 minus I2 plus 6I1 minus I3 minus 9 equals 0. Or 9I3 plus 3I2 minus 6I3 equals 9. The I2 loop. 3I2 minus I1 plus 6I2 plus 5I2 minus I3 equals 0. There is no minus 9, and that's a typo. We're going to get rid of that. So that equals 0. Okay. In loop 3, 3I3 plus 6I3 minus I1 plus 5I3 minus I2 equals 0. Or minus 6I1 minus 5I2 plus 14I3 equals 0. In standard form, this is what it looks like. And again, your cross diagonals. Plus, whoops, there's a plus there, it should be a minus. Minus and minus, minus and minus. There's a typo right there. We should have a minus there as opposed to, these should be minuses. You should be able to check and see that that's correct. Okay, so figure 5-4, another one. And again, this now has multiple paths and multiple voltage supplies. You would have to use superposition before, but now we're just going to use the mesh method, and we're going to solve this with 3 equations and 3 unknowns. Okay, so this one is 5-4. So the first equation we write is what? 6I1 plus 3I1 minus I2 plus 6, because we're coming in from the plus side, minus 9 equals 0. So that satisfies this loop. So we have 9I1 minus 3I2 equals 3. In loop 2, we start up here, 2I2 plus 3 minus 6 plus 3I2 minus I1 equals 0. So we come around here. If we walk in from the minus side, we write minus. If we walk in from the plus side, we write plus. If it's a resistor, we just write plus, and away we go. All right, so that gives you an idea of mesh equations. Multiple unknowns, multiple equations. So you get 3 equations, 3 unknowns, 4 equations, 4 unknowns, whatever you get, but that's it. Now, there's another way of doing this, and this is called node equations. And node equations have an advantage and they have a disadvantage. The advantage is you get one fewer equations than you do with the mesh, but they have a denominator, which makes the problem a little more dirty to work with. So we're looking at this time for KCL instead of KVL. We're using Kirchhoff's current law. So here are some examples of Kirchhoff's current law. So basically we say here, well, I don't know what the voltage is. I know what the voltage is here, but I don't know what the voltage is here. But I can write it in such a way that I call this my VB, or voltage across at this point, and I can describe it, the current into and the current out of this circuit as what? As the current in equals the current out, which is Kirchhoff's current law. So again, we can do that with this circuit, and as we start writing, we can say, okay, the current in has to equal the current out. I1 equals I2 plus I3. How do you write those? How do you write those? That's a good question. Well, in this case, we write it's volts divided by resistance. Hopefully you see that. Volts, which would be 9 volts minus VB. In other words, the voltage here minus the voltage here is 9 minus VB. We don't know VB, but we do know that it's a variable. So now this is not our I1 or I2 or I3, but this is our point of reference. Okay, so this is my VB. So 9 minus VB over 6, that's the current in, is equal to VB minus 1. In other words, this has to be higher than 1, VB minus 1. It doesn't have to be. It could be lower, but it probably is higher. Divided by 2. VB minus 1 divided by 2. This is VB over 3. Okay, so this is equal to VB minus 1 over 2 plus VB over 3. All right, so solving all the way down, we get VB equals 2 volts. And we can find then, from that, we can find our I's, I1, I2, and I3, and away they go. And also we can solve multiple equations, or multiple, if you will, you can combine resistors. So again, this is the same circuit, but with multiple resistors. Okay. Here is the circuit for 5/8. Solving for VB here, it's 6 minus VB over 6 equals 3VB minus 36 plus VB minus 12. So here we actually have 6 volts on one side and 12 volts on the other. You say, well, the current's going to go this way, but if I solve for VB and find that VB is actually less than 12, the currents are actually going to go the other way, but I solve the same problem. I1 equals I2 plus I3, and then we solve for it, and we come up with negative answers. If VB comes up to 7, we can see that I1 is really 6 minus 7 over 6, or minus 0.167 amps. I2 is 7 minus 12 over 2, or minus 2.5. And I3 is 7/3, or 2.33 amps. Okay, so now we're going to add power supplies into all 3 loops. How will you do that? Well, voltage at A minus voltage at B is the current coming in. Voltage at A is 10 minus VB, which is my unknown voltage, divided by 4K is my current coming in. My current coming in is 10 minus VB over 4,000. My current going out is I2, which is the one going across, and then I3, the current coming down. So it's VB plus 2, because I'm going to 2 below 0. In other words, it's VB minus a minus 2, because this is minus 2 volts. This is 2 volts below 0. So that's VB plus 2 divided by 6,000 plus VB minus 5. So a VB minus 5 over 8,000. So this is my answer. This is my equation for finding VB. And again, we can solve for VB, VC in multiple equations, multiple unknowns. Here we discover that if we have 3 panes, and there are 3 panes in this, as well as this, that solves to 2 unknowns, 2 unknown voltages, VB and VC. Okay, so that gives us the 2 unknowns. You add them up, you find that VB is equal to, we don't have a solution for it, but we do have the equations. So this would be my equations for my 2 unknowns, VB and VC, and you can solve for those, and you can find out what VB and VC actually are. So now we're going to ask you to write the loop and node equations for each of the following. So it's going to take me a little bit of time to get set up here to do that, but I'm going to work on that, and we're going to solve those problems for you. Okay, so we're just going to write the equations. We're not going to come to we're not going to get the answers. We're just going to write the equations, and that's what we're actually asking for, is just to write the equations. Okay. All right, so we're here, and we're gonna get the drawing board up, and we're gonna work on that. Okay, so we'll work on getting the drawing board up. Okay, so we've got the drawing board up now, and we're just going to go through and work these problems, and we're going to see how we're going to do on these problems. Okay, so okay. So the first one is we have 20 volts. So the first problem is 20 volts. And we have 200 ohms, and we have 500 ohms, and we have 300, we have 10 volts. Okay, so we have a plus. So we do the mesh first. So I'm going to draw a loop and call this I1 loop. Do another loop, call this the I2 loop. And I have 10 volts over here on this side, plus on the top. So I have my I1 loop, so I say minus 20 plus 200 I1 plus 500 parenthesis I1 minus I2 equals 0. That's Kirchhoff's voltage law for the first loop. The second loop, I have 10, because I'm coming in from the top, plus 500 I2 minus I1 plus 300 I2 equals 0. And I solve. Okay, so I go to standard form, and that's as far as I'm going to go. I have 200 plus 500 is 700 I1, and I have that. I check those off as I use them. minus 500 I2 equals 20. Bring the 20 over to the other side. Now for the I2 loop, I say I have minus 500 I1, again that's your cross diagonal, plus 800 I2 equals minus 10. And those are my two in standard form, my two equations in standard form, and that would be all I would ask. So what do you do for, this is mesh. Now what do you do for node? Node equations are, we call this our VA terminal. So it's 20 minus VA is my current N divided by 200. That's my I coming in. And that's equal to what? VA minus 10 over 300. That's the current going out, the I2, plus the I3, which is coming down, is what? Plus VA over 500. And you can do whatever you want to with that, but that gives you a that's your only equation you need. That's your whole thing. So you say, which is easier? Is this easier or is this easier? Doesn't matter. You decide. But they either can be solved. Either way can be solved with a good calculator. So again, 20 minus VA over 200 plus equals VA minus 10 over 300 plus VA minus 500. Okay, that's all you need. So that gets us our first problem done. And our second problem is the same, except it's different. So it's this one with 10 volts and so we have 2K. This is our B point. 6K. This is our C point. This is 1K. And 4K. And 3K. This is my I1 loop, my I2 loop, and my I3 loop. So basically in my I1 loop I have what? This is my mesh equation. Minus 10 plus I1 minus I2 quantity times 2K plus I1 minus I3 quantity times 4K equals 0. Second loop, it's my I2 loop. I2 times 1K plus I2 minus I3 quantity times 3K, excuse me, times 6K So it's the I2 loop is this one and this one and this one. So it's I2 minus I3 times 6K plus I2 minus I1 quantity times 2K equals 0. And you can simplify these down. I'm not going to, but you can, and that gives you your three mesh equations. My I3 loop is what? Well, it's I3 times 3K plus I3 minus I1 times 4K plus I3 minus I2 times 6K equals 0. That's your mesh equations. Now, what about your nodal equations? Nodal equations, you come in here and you say, okay, now what would be my, this is 10 volts, so it's 10 minus, my current coming in is 10, the current coming down this row is 10 minus VB over 2K. What's the current going out? Okay, the current going in is 10 minus VB over 2K. What's the current going out? It's VB minus VC over 6K plus VB over 4K. Everybody see that? VB minus 0 over 4K. That's one node equation. What's your other node equation? My VC would be what? Current coming in is 10 minus VC over 1K is equal to what? VC minus VB over 6K plus VC over 3K. And you solve for VB and VC and you're done. And that's how you do mesh and node equations. Take care and have a good day.